Hello, this is John from caveofprogramming.com. In this tutorial, I'm going to give you some tasks that you can attempt if you want to with this project, and I'm just going to make a few sort of general remarks. So I tweaked the colours a bit and I got it looking like this. One thing I don't like about this is it's sort of speckled with black. I'm not completely 100% certain that there's not some kind of, not exactly error, but something in the logic of my code that's not optimal. You do see less of this speckling if you increase the number of iterations in Mandelbrot.h, but what happens is the colour also changes, which is kind of strange. I'm not sure of the reason for that, because I would have thought the colours would stay the same. But I guess if you're doing more iterations, then you've got, I don't know, more pixels with higher numbers of iterations. Somehow the distribution changes, or there could be some error in the logic of my code, but either way the colours change. So if you want a really tough task, because I haven't figured it out myself and maybe it involves knowing more about fractals than I do, then you could try to get rid of this speckling, or just try to make the colours remain the same when you increase the number of iterations. Now, an easier task, by the way, do let me know if you figure out how to do that, because I'm very interested to know the answer. If you want a bit of an easier challenge, one thing you could do is try to optimize this code. So there are profiling tools that tell you how long each function takes, but it's also clear that there are just some blatant opportunities for optimization here. For example, we're doing this calculation over and over again, I suppose, for the same numbers of iterations. We could pre-calculate that. We could, in fact, pre-calculate probably quite a lot of stuff in here and store it somewhere before we go into these loops. This is in fractalcreator.cpp draw fractal. So I think this has quite a lot of scope for optimization. So I just kind of puzzled for a second there by what this warning was. Let's just take a look. Unused variable color diff, and I've got two of those in here. Well, there's one optimization right away. We can just get rid of these now. Okay, so just looking at this and seeing if we could make it faster is another good task to try. Another quite ambitious task, but you should be able to do it if you look at my beginner's C++ tutorial, which is free, and combine it with this one, is here we've used just a static bitmap to render the fractal. In a beginner's tutorial, I showed you how to use SDL to draw things on the screen. And if you do a bit of Googling, you can easily find out how to get mouse click coordinates as well in SDL. So you could upgrade this to a program where you can actually just click on a spot and then it will redraw it, drawing the entire fractal. Drawing a fractal is inherently a slow process, but you can certainly optimize this a bit. And also, a lot of fractal programs, they'll draw a fractal with a low number of iterations and then draw on over that with a higher number. So there are successive waves to at least give the user some sense of progress and let them preview the fractal quickly. The kind of waves of drawing until we finally get to the end sort of wave of drawing, which has the maximum number of iterations that the user has selected to use. So turning this into a program that you can actually click on and zoom in using SDL would be a really good challenge, but I'm not going to do it myself because I think we've got enough for one tutorial really. And in this tutorial I wanted to show you how to use bitmaps, how to write to a binary file format. Another thing that you can do, which I sadly haven't been able to do but I would have really liked to, is there's a tool called Valgrind, I think it's pronounced. Valgrind, some sort of Viking name. I can't use this because it's not compatible with my version of Mac, but if you're using an older version of Mac than I think 10.10, or if you're using Linux, then you could use Valgrind. I'm not sure if there is a free equivalent for Windows. I don't think this runs on Windows, but this allows you to check your program for memory leaks and things like overwriting the end of an array and stuff like that. So it's a very, very good thing to do if you're going to release software commercially. I wish I could have done it for this tutorial, but I don't have, I couldn't find any free alternatives to do this with. So I'm just hoping, I've tried to be careful, and I'm hoping I'm not writing over the ends of any arrays or anything in this program. It seems to be stable. If you do write into memory you've not allocated, or you read memory that you've not allocated, then you could end up with your program intermittently crashing, which is really horrible. I think that's just about all I've got to say on this. So we're going to leave it there, and you could certainly take this further if you want to. If you do get a chance to run Valgrind and you find anything wrong in this program, do let me know, and I can add another video with listing bugs. Unfortunately, it's very common for programs to end up with bugs. All you can really do in C++ is program very, very carefully, and then if possible use a tool like Valgrind to check it at the end. Okay, so that's it for this tutorial. Until next time, happy coding.